Let us begin. Thank you very much for joining us today for our webinar entitled 12 Inventor Tips and Tricks. My name is Ajay and I will be your presenter today. We'll talk a little bit about us, who we are, what we do, and so on. Then we will move on to a little bit of general Inventor tips that we can use to just simplify our design process. We'll talk a little bit about model representations, design accelerators, certain Inventor environments that could be useful to you going forward. And then we'll speak a little bit about the interoperability between Inventor and other software packages. My name is Ajay. I am the technical specialist in the manufacturing and process plant department at Baker Baines. I am a qualified mechanical engineer with experience in design and manufacturing. I've spent some time working as a project engineer and a project installations manager in the construction industry. So moving on, we'll talk a little bit about what we as Baker Baines actually provide as solutions. We are a Autodesk Gold partner, so we consult with regards to Autodesk software, but as well as we partner up with companies such as ClearEdge, Cool Orange as well. We offer a consulting service where we will be able to assist to move to digitize and to move in towards the fourth industrial revolution and just sort of keep up with that. The education aspect of it, we do a lot of training courses, we do project and user-based training, as well as offer a self-paced e-learning portal, which we'll speak about a little bit later, predominantly in the building, civil, process plant manufacturing, and energy industries. So first and foremost, I'm going to give you a little, I'll give you a couple of minutes to just take a picture or a screenshot of this image. These are a few shortcuts that you can speed up your design. I mean, you get to a point where, especially with the advanced users, you get to a point where you're looking for small ways, little ways to speed up your design. And this will allow you to speed it up incrementally so that you are able to just save a bit of time here and there. For example, if we look at a couple of the general ones, we've got the Control A is to select all, Control C, same as Windows, Control N displays the new file dialog box, and F2 does a rename. So similar thing in terms of placed features. Your F7 gives you the slice graphics, which temporarily removes a section of your drawing if you're doing sketching inside of a profile. Which, if you're struggling to, because you then don't have to go in and change it to a wireframe or do a slice using the ribbon. You can just quickly press F7 and it'll cut it up to the plane where you're actually making the drawing. Let's then move on to the next page of shortcuts, which gives you certain shortcuts that you can use in the different Inventor environments, such as your assembly, your drawing manager, work features, and the view. Now, the view thing is quite useful. I like to use the Control, Shift, and middle mouse click, or Shift and middle mouse click in this case, where you can rotate your view and have a look at your part model or your 3D model from every angle, or whichever angle you feel like looking at it from, or you need to look at it from, rather. Press Shift and F5. It moves to the next view. If you want to pan, you will press Control and the middle mouse, the mouse roller. If we then move on, we will be talking just briefly about sketch constraints, what they are, how they work, why they're useful. Here I've just got a drawing with a sketch in it, just for observation. If we open up the sketch, you can see that in an Inventor, we all know that if we don't actually constrain things, they move around a little bit. Now, this is an incompletely constrained object, and if we had to actually have a closed profile which was incompletely constrained or not constrained at all, obviously if you're going into the sketch and just clicking on a line and dragging it, it completely skews your extrusion or your rotation, depending on whatever it is you do with it. So just to give you an idea, your constraint section is sitting over here. All of your different constraint options are available here, from your collinear constraint or coincident constraint to a perpendicular constraint, which, if you have the constraint settings activated, by clicking over there, you can actually see that there's an inference constraint. Everything is, I've set this thing up to actually infer all of the constraints that are available. Now, the inferred constraints are actually just something that occurs as you draw. The inference actually takes place. Where under other circumstances, if I had to take away, let's say, for example, this one and that one, and say, okay, what happens here is when I draw a line from here, it doesn't infer the horizontal constraint or the 90-degree perpendicular constraint. So that's one of the things that you can do, but on the same token, you can actually just draw the line and then create the constraint between lines. In the same way, we would like to dimension it. So if we make an equal constraint, for example, we can actually take that one and make it those two lines equal to each other. Then the next, let's go back to our constraint inferences, and we could put everything back where they were. If we remove, let's leave that one out. If we keep the horizontal one or the vertical one off, you'll also note that you can use the parallel constraints to do pretty much the same thing. So as you see, it doesn't actually pick up the constraint when you actually make the drawing in this way, or you can, once you drop the line, you make it parallel. Another thing that we can actually do is to actually leave that inferred constraint in place, put it back where it was, and then you say, okay. And what we can do is we can draw this line, and as you'll see there, it actually freezes, and you can see the icon next to the cursor that we are looking at a perpendicular or a vertical line rather. Okay, and then to actually equate it, you would actually pull that coincident constraint there and define it. Now, at this point, you'll see that the sketch currently is not completely constrained, and I'll tell you why. Let's then actually do this constraint. If we make that one equal to that one, yes, it says it will make it over constraint. Then you say, all right, you say cancel, it's fine. Because what we've already done, we know that the height of this thing is 50 mils. And this line needs to be 50 millimeters for it to actually attach or connect to be on the same plane or line axis as the bottom section of this line. As it stands, we have all of the constraints in place. What we have here is we've got pull constraint as well, and then let's start constraining our drawing correctly. So if we accept that, you'll see that this constraint is sitting in brackets. It gives an error when you try to constrain it because one, we've given this dimension, we've given this dimension, and this dimension is also given. So the length of this line is inferred because that is the constraint, and as such, if you try and constrain it with a value, that wouldn't work, or it would actually cause it to go skew and to actually self-contradict. And if it's self-contradicting, it tells you that it's an inferred dimension, and that means that if you change anything here, like so, what it does is it'll actually change in accordance with it as a driven dimension. So that's essentially where. So if you actually pull the drawing, you can see that it's actually moving around. So this is where we would need to constrain. So if we just press undo there, and we look at, there we go. Now we see that the length of this line is given here, and the top of this line to the origin point is also at 50 millimeters as given here. Now you'll notice that in the dark background, the fully constrained sketch shows up as a white enclosed sketch. Got a lighter or a white background, that's as per the standard Inventor background. You will note that this fully constrained sketch will then will be drawn in completely in black. And as such, this is essentially what a fully constrained sketch will look like. Now, the next thing we will quickly look at is in the constraint system, you'll actually see something called, in the constraint setup mode, you'll see something called the relax mode. So now if you enable relax mode, there are certain constraints that you can relax so that you can actually modify your drawing a little bit if needed. So let's show all the constraints, and you'll see that all of these constraints are now available. And as you can see there, now if you select relax mode, which is on at the moment, F11 would be the shortcut key for it. The certain modes that are relaxed, you can see that these tolerances and certain constraints will be relaxed just so that you can temporarily update your sketch if you need. That's essentially the way in which you would fully constrain a sketch. Then you could give it a little bit of a relaxation just so that you can make one or two updates to it, and then you can put it back to normal constraints as well. You can disable it here, you can disable it there, or you can just use F11. Moving on to the next section, we'll be talking about model representations. We'll first talk about a thing called model states. Now, in model states, we'll see that on the top over here, there's a folder. Every sheet metal or solid part file will have a section called model states. Now, if you open that, you'll see when you open that in a normal model that you've created, 3D model that you've created, you'll see that there is a primary model state, which is the standard one that is available all the time. Now, what we needed to do here is in the primary, in this particular instance, what I've done is I've created a flat sheet metal part in the primary model state. Using the various model states, you can actually create representations of different states of the model. You can even create different types of models. Now, for example, if you had a solid part that needs to go fit into an object, let's say an engine component that requires a threaded hole on the side for an additional component. If the need arises, you can represent the same model in two different ways, with and without that component. Let's just show you what this looks like. Model state number 1, I've got one flap up. Model state number 2, I've got that flap up. Model state number 3, I've got that flap bent. And model state number 4, I've got that flap bent. And then 5 is the entire thing. Now, if we go back into the primary, I can create. How do you create a model state? You go onto the primary, you right click on the model state folder, and then you say new, click on new, and you give it a name. Press F2 to change that. I'm going to call it 6. Remember, whenever you do something to a model, or whenever you want to add a different state to a model, you would select the active model state, or make that model state that you want that particular aspect to be in, and you make that active by double clicking on it, okay? Or by right clicking and saying activate. When model state 6 is activated, you'll see that all of the that we used have been suppressed. Now you'll see in model state number 1, you'll see that the one fold feature has actually come up, and that feature is unsuppressed for that specific state. So in your model tree, all of the features that you've created will remain. They will just be suppressed and unsuppressed depending on how you've set up your model state. So just to show you, model state number 6 is selected now. What I'm going to quickly do is I'm going to make a sketch on the plate, draw a line quickly across. So remember that model state number 6 is the one that we've actually selected as our active current model state. So what we're now going to do is I'm going to actually fold along the bend line. There you've got a folded metal part. Now you'll see that it's folded right down the middle, and each of the different model states will show a different state in which the model can be visualized, shown, or manufactured. The next thing about model states is that when you do a drawing and you bring your base, well, any part really, and you can select your locations. However, you will note that there are model states which you can actually select as the visualized or represented part. So using the model states 1 to 6, or primary, which will be the flat model, 6 will be that middle folded model, and then if you select OK, that actually shows you what state each model is in. So you can represent this in your drawing as whichever model. Now you can then use your sheet numbers or your naming to define how that particular model is set up. So that's the one model representation thing that we can look at. The next thing we will look at is positional referencing. Now, positional referencing, a very similar concept. However, positional referencing is only available in an assembly file. The reason for that is it shows constraints and joins to actually define positioning, or the relative positioning of the different parts in your assembly. Now, for example, in this particular instance, you'll actually note that you've got model states there. Now in here you can add substitute, same as what we've done in the part model. Now you can substitute the different part model states in an assembly as well, just to show what it will be doing. With positional representations, you'll notice that in the assembly environment, in the model tree, you'll notice that there's a folder there called representation. So if you actually expand on that, you'll see there's a default viewer, which is, you can change your views as well. You can add default views to your primary view by just clicking on new, but this is not the purpose of what we're showing. So let's continue with positional representations. So here, what I've got is I've just got a small bracket that's been grounded with a little bucket that's in a specific position. Now, if you want to look at it in various positions, I've got them at different angles in this particular instance, but you can change that to distances. If you've got a flush or a mate constraint in place, you can actually set it up with different distances. The primary is actually a flat model, but now I've got a 22.5 degree, a 45 degree, 67.5 degree, or a 90 degree, right? How do we fix that, or how do we update that? We will then add a new one here, and in the new position, F2 once again to change the name, and I will call that 75, right? Now, when this positional representation is actually active, you would then go to your relationships and then modify the angle. Now, in this particular instance, you add a value there and you say 75 degrees, and you say, all right, now it goes the opposite direction, and now it goes the opposite way around. So it just depends on how your angle has been set up, right? So this is the different positional representations that you can have for various items. And I think a very nice idea would be if you've got a limited movement part, that like a vice grip, for example, that you can actually put on a table and you can show the different levels where they stand and where they move around. Very, very useful. And where it becomes even more interesting is when you actually do a drawing for this assembly is, let's add our positional representation. Let's put our base part there. Here, in this situation, what we've done is we've created a position view in the primary state. So you can actually do it like this as well. So let's just remove all of the views, and I'll quickly show you. Is if we do a base part here, you'll see that you can change the positional representation that is actually available to you. Now, you can see that that's the positional representation that's in place. Now it makes it, let's take it one step even further, and let's place a primary positional representation in place and side drawing. And then once you've got this in place, there's a selection here called overlay view. Now, if you select overlay view, you can overlay a specific model in a positional representation or a model state even, and show the overlays. Right now, you can show both the states of the model, both of the positions of the model, multiple positions of the same model in an overlay view, showing the different levels and states and positions where they can be located, and the model states can also be done as such. So this is quite a very interesting and handy tool to show a representation of an assembly that you've created with a moving part and the different positioning situations of that particular model part. That also allows you to define and visually show what the different positions will be, and that assists in getting a full view of what is available and what is possible with the part that you have created. Now, the simplified tool, some of you may be aware of it, or a part of it anyway, as the was used to be called the shrink wrap. The shrink wrap is also added as part of the simplification options. You've got the shrink wrap that's available as well, or something similar to the shrink wrap, which is basically a model representation as well. We'll talk about that in brief very quickly. If you click on simplify, you've got a vast array of tools with which to simplify a model. Now, some of us may be asking, especially the new users and the non-users, will probably be asking, but now why would we want to simplify the model? In this particular instance, not really that important. However, when it comes to larger models with a lot of screws, bolts, nuts, holes, and a large number of features that are in play, you will find that as in the assemblies that it takes up a lot of resources. Those resources sometimes can slow down your model and just keep the model size and resource usage down. You kind of try and remove the simplifications, and in some cases as well, you also want to remove a lot of the nitty-gritty design aspects of it in order for a submission to a client, for example, or to submission for approval, anything to that nature. You would just want to show a representation of what your part looks like without giving it too much detail. Here you've got a list of simplification options. So you've got to remove the least detail, so that removes the small parts and some features, remove moderate details, and in this particular instance, it's going to remove the entire thing. Now let's look more into, so these are like your preset methodology, preset ways. So now here you can select your model states that you want to show, your view that you want to show, and your position that you would like to show. This is now a replacement with envelopes. No, we're not replacing with envelopes in this particular instance just yet. We will get to that. You can exclude parts by size, everything smaller than 300 millimeters. So if we make it smaller, like let's say if I had smaller holes, I could remove everything below a 50 millimeter diagonal size. Set parts that I can exclude as I would like. I can select the part and have it excluded. Then what you'll see as well is that you've got part size, and then you've got remove features, whether it's like a hole, and you can pick up your hole size range. So it can be from 1 millimeter to 10 millimeters. So you still want to represent the larger sized holes with the gaps in the tool and so on. As such, you can actually work with any one of these filters that you can start removing features. And here, what would you do in terms of your output? You select a new part file or a substitute or a Revit model. So Revit model part, which we'll talk about a little bit later on. We'll go into a little bit more detail about that. But now you'll see if we've got envelope replacements, you can actually say everything in one single envelope. You can make it part Each top level component can be an envelope or each part. Now, this one and this one are the same because there are only literally 2 parts in this particular assembly. But when you've got bolts and nuts and washers and all kinds of small intricate bits and bobs that would make an assembly to work, you can make it so that each one has an envelope of its own. For the space requirement in terms of an assembly or to put it together in real life, this enveloping concept actually works very well. Next, we will talk a little bit about the Inventor viewer and the shared view capabilities that Inventor possesses. We're looking at here is, this is a collaboration, this is a collaborative idea. So what we can just do is if we go to the Collaborate tab and we go to Shared Views, what it does is it creates a shared view. There's already a shared view that I've created with the previous folded metal part, but let's create one for this instance, and we just say, if we go into the shared views dialog, and we click on new shared view, what it does is it takes our positional reference assembly and shares it online. Once that happens, once that is actually created, while that's happening, we can quickly talk about the options that you've got with the shared view. So you can either view it in a browser, you can copy a link and send it to somebody via email or on Teams or whatever the case may be, or alternatively, you could also look there and you can extend it or delete it. So now this is the view that I've just now created. So if we click on the 3 dots there, or we can just click on view in browser, click on the 3 dots, view in browser. What it does is it takes you to the internet, and you are then able to view a part. And while we wait, you're able to view a part and do a whole bunch of commands to it. I'm going to quickly sign in so that we can see all the different options that are available to you. You can view it even without signing in, or you just don't have a couple of these options. You won't have the markup and the explode option that is available to the people who have signed in with an Autodesk account. Now you can take a screenshot, print, share it as well to somebody else. If we look at the properties, you can see if there are any properties that have been added to it. And if you look at settings, there's configuration settings that you can do, so progressive displays and appearances, and there's a few things, the large number of customizations that you can do. Now the views that are available, you look at the scene, you can look at it. Same view cube that's available in Inventor is available here as well, and you can actually show all of these different orientation views for yourself. And then the most interesting part is we can actually add a markup there, and then when you save it, you'll see that it's in the shared view. The markup is now available. Then you can add a copy of it and send it back to the original author. And then if you look at this guy now, if you open that object, you'll see that now the markup is actually available to the person who created the view as a shared view. You don't have to, it doesn't actually show up in the main model, but it comes into your shared view. So you can collaboratively mark up and add and change things on the fly with whatever distance you have, you are away from each other between the collaborators. Then we will quickly talk about creating a 3D PDF. Very similar concept, but what actually works out quite nicely here is that you can use the same idea here. Let's actually close the shared views to continue. Go back to our file. So in this case, we're not actually creating a cloud-based model that people can view and mark up. We are creating a PDF model that can be sent out. If you really want to look impressive to your clients, you can just quickly go to File, and then if you look at Export, you can see there's a couple of export options. You can export to 3D PDF, PDF image, CAD, any other CAD format, or a few other CAD formats. Let's just quickly run through them. You can do them, you can use CATIA, object files, parasolids, SMT, step files, STLs. But we're not doing that now. We're talking about 3D PDFs. So let's export this to a 3D PDF. Now, when you do that, this dialog box actually opens up, and then it'll ask you what design view representations you want to allow it to go through. What visualization quality do you want? What scope? So if you want to limit entities in the selected view representation, so if you select these design view representations, you can limit it to that, but let's click on all entities in this case. Then you select the template that it's actually coming from. So it has a template to create a PDF. Now, if you go in there, you'll be able to see what that's about. Then your file output location. So this is where your file will go and land when it's finished. I'm going to click on View PDF when finished so that we can see it immediately. So if we click Publish, it goes and publishes, and I'll show you what it looks like. I already have taken the liberty of doing it before, creating one in the past. There is a 3D PDF that was previously created with our earlier folded model. So you'll see that you've got a 3D object that you can look at. You can look at the different views. So let's go back to primary view, and it takes you back to where you are. You've got the, if you toggle the model tree, you can see the model tree. You can see all of the different positional representations, and you can see you can select whether to have the datum lines in place or not. So let's say, for example, the planes and lines and even the center point can be shown. You can actually activate or deactivate the different views. You've got the 3 different views: primary, default, and view 1. And if you've got more of those saved, as part of your model, you'll be able to do that. Now, if you look at the previous one that we have, all of this information is populated as part of this comes out of the EI property. So your part number, your revision number, who's the designer, who's the engineer, whatever notes you added to it, that all come through in your primary revision. So you'll see here we've got primary, isometric, front, top, different views that have been selected and saved. Now, this is quite a helpful little tool. You've got a bunch of options there here that allow you to view it in different ways. Got different camera properties that you can use. You can measure it in 3 dimensions, and it'll tell you, okay, hold down Alt to rotate, hold down Shift to pan, etc., etc. So if you go measure, you can then measure from here. It's an as the crow flies measurement. So let's rather pick up 3D measurement tool there, right? And that's more or less what the dimension will be. And that adds it in there as a comment. So you see there's a lot of things that you can do with this 3D PDF. And next, we'll talk very briefly about design accelerators. I'm pretty sure most of you know about these. In the assembly environment, we'll talk a little bit about the bolted connection that comes in the assembly environment. This is just a random couple of plates that are previously done. In here, you can go to design, and under design, you've got a whole bunch of design accelerators where you would also find the frame generator. Now, using the bolted connection, what you can do is you can either select your start plane, then select your first. So your first linear edge tells you how far away from that edge it'll be. So we make that 20, and then the second linear edge will ask you same thing. Let's make that 20 as well. Now we've got the center point or center of your hole. Now you select that, you've got your linear edge, and then you work out where is your termination. Here, by using this section here where you say click to add a fastener, it'll then automatically pick up that you're looking to get a bolt head. There we go. Now we pick your bolt type, and then if we add a fastener, it automatically picks up, okay, now there's already a bolt, so now we need a washer. So what it'll do is it'll actually ask you to put in a washer. So I'm not going to do that now. At the bottom or at the end, you also add a fastener, and then here you can pick up the nut or a washer or a nut. And if I pick a washer, then once I've picked up the washer, then at the end, you can then also pick your nut. What's actually pretty cool is you can actually create a bolt set template. I've gone and previously created one. So if you click that and you say set, it goes and automatically selects your bolt, your washer, your 2 surfaces. If there's more surfaces, you can pick it up as well. Then also the washer and nut. So if you apply that, what it'll do automatically, it will create a bolt, the washer, and the full bolting assembly for you, without you having to actually go in and place components one at a time. That's your bolted connections. Useful, very interesting, and very impressive in terms of time saving. Moving on to the next thing, we're talking about the frame generator, the end cap, specifically the end cap feature on the frame generator. If we go to the frame, created a frame already, we use, I think most of us are already aware of how to create frames, where you create a system of lines, and then you can drop your frames depending on how you want the frame actually to be set up. So the frame can be, just to pull us back a little bit. So if we say insert frame, we've got options of the type of category we can work from, everything from angles to Zs. The standard will be depending on what standard we're working in, the part family or the standard family that we're working on, your sizing, your material, and your appearance. So all of that can be selected when you do the frame generator. Most of the time when you've got a frame like this, right? Odd little frame, but when you've got a frame that's actually set up like this, most of the time when the frame is cut, you've got a sharp edge. Now, do you really want to go and fill it or create all of that? What we'll do instead is to create an end cap. And you've got 2 types of end cap. So you can place it on the outside, or you can place it on the internal position. So I'll show you both quickly. If you select that face, it creates an end cap on the outside and gives you the frame member naming option as per the frame generator. And you say, all right, And there you've got a cover that you can actually specify in your model or in your bill of materials. If we select an end cap there, you can also tell it to go on the inside. So if we do that, it goes and sits on the inside of that surface. And your thickness can also be changed. You can actually make it 1 millimeter. So that's what you can do there as well. All right, so that's the end cap. We'll talk a little bit about Inventor environments now. So there's a couple of environments that can prove quite useful. First of all, we're going to talk a little bit about the 3D dimensioning environment. Now, this is also known as the GD&T, and here we can keep the visual cells a bit more visible so that we can actually see what's going on. Now, if we go into the annotate section, a ribbon or annotate tab, in the ribbon, you'll see a whole list of options. Now, you've got export options here as well into your shape views, and on top of all of that, we also have three-dimensional annotations and notes. So if we look at 3D dimensioning, you can dimension your model part and add your dimensional comments like that and make it so that it's visible in your 3D environment. Now, what's actually very cool about this is that you can add a whole bunch of notes in all forms of on all the different planes. Your surface texture we've already done. We can create a thread note there where it tells us everything we need to know about the thread in the hole. All of this can actually go and be pushed out using the 3D environment. Now, from the 3D environment, this is just the thing. You can actually add general profile notes. You can stick them in whatever quadrant of your screen. Any notes that you want to add, you can add them in another quadrant of your screen, and leader text you can also add. Using this, right, let me save that. And using that, we can actually bring in our base view here. All right, so now we've got our 3 views. Okay, so if we go to the annotate section there, you will also notice that there's a feature here called retrieve model annotations. You can click on that and you select the view that you want to retrieve the annotations on now, or let's just use that one there, but that one looks a little bit of a mess, so let's not apply to that one. With retrieve model annotations there. Now you'll see that these model annotations are also movable. So you can have the model annotations in your 3D model and then also pull them through to your drawing. So that's that's your 3D dimensioning. Then we'll quickly talk about the weld calculator. The weld calculator, very interesting concept. Now, I've already gone to, if we go to environments, you'll see here that if you go to environments, there's a section where you can convert it to a weldment. Once you've converted the assembly to a weldment, it becomes a welding assembly, and then it stays a welding assembly, and all of the features that goes with it remains in place. That adds a tab to the top there, which says weld, and you've got different options to add a weld to it. So you can add your weld into your welding section. However, what I want to show you right now is the weld calculator, which you find over here. It's very interesting. You've got a whole list of different weld and step solder and solder calculators that you've got available. Let's quickly go to the fillet weld calculator. And what we have here is we've got the force that is experienced by the part in all the different directions. So you've got a bending force, you've got an axial bending or shear acting force that's in your different directions. This calculates your X and Y components of your force and so on. You've got all these different methods of bending moments as well. So if you've got all of these different methods, you've got your weld height and you got your weld length. So if we take the dimension and make it a weld height of, let's make it 2 millimeters, and we've got a yield strength. So let's select our weld material. I'm going to use the top one to show. And then you've got a yield strength of 205 megapascals on this one. You've got an UTS or ultimate tensile strength or tau of sigma of 390 sigma max. And then you select the safety factor that you want. So I'm going to go with a 5 times safety factor, and then your allowable stress will be selected. Using all of this engineering information of materials, forces, and what is going to happen to your part, you can actually go ahead and calculate all of these values. Now, these values, I'll show you what they are, but if you look here quickly, you'll notice there's a couple of extra little options over here. So if you click on that one there, you will see that there's a fillet weld calculator that's in place. Gives you your project information, whatever project information you have in place, and status. Then your guide, all your selections over here. So our pinks are our selections. Now you'll see here that your allowable stress tau A is 41 megapascals. Your minimum weld height is 0.37. Your minimum weld length is 18.3. This is to get the strength that we need out of this particular part. And your maximum weld shear stress. And then your maximum axial force, because we calculated on an axial force, is 8,200 or 8.2 kilonewtons. This is just something that allows you to work out what type of weld you need and where you need and how you need to set it up. Next up, we'll talk about the tolerance analysis. I'm not going to go into it too much. The tolerance analysis is a additional add-on tool. It's a tool that allows you to look at your assemblies and analyze the way that it's been put together. So if there's any issues with your tolerancing the setup, or if there's any interferences, it allows you to do that. There is an interference calculator feature anyway, but this just gives you a full breakdown in numbers as to how they are connected to each other, where the interferences and what the tolerances should be. Next, we're quickly going to talk about interoperability. There's a couple of things where we'll talk about. Firstly, we'll talk about Autodesk AutoCAD to Inventor, not a very difficult thing to do. So there's a couple of ways in which you can import an AutoCAD file. First and foremost, you can import it by going into the sketch, so creating a sketch, and then see that little button over there, you can click on AutoCAD, and then you bring it in. Now that's if you want to import an AutoCAD sketch. Now that's if you want to import your sketch into a specific part model that you're already busy creating. Now, if you want to do that if you want to create a part out of a completely separate part out of an AutoCAD file, you click on File, go to Open, and then you say Import your DWG. Once you've imported your DWG, click on the file. So here it picks up what layer you want to import from your AutoCAD, and then you select what you want to do with it. You have the option to bring it into a 3D data, as a 3D sketch, or you can bring it in as a 2D sketch. So let's finish that off. And what it does is it goes and creates a new sketch. Now, both of these sketches can be dealt with in the same way. So when you're finished with the sketch, you can then extrude, revolve, whatever it is you want to do with it. So let's do a revolve, select the axis. You say, okay, so that's just pulling it straight from an AutoCAD file. The next thing we will talk about quickly is a interoperability of Inventor into Fusion. So using Inventor, we can export a part model that you've created into Fusion by going to the Fusion 360 tab. If you've installed Inventor and then Fusion 360 in there, you can then send it to any one of these environments within Fusion. You click on modeling and then you continue, and it'll upload it for you. You pick a project, you pick a folder within your project. I'll just do it in there. All right, so you select that. It goes into your Fusion project as a Fusion file. And once it's uploaded, you go to your Fusion quickly, and then you'll see here, now it's uploaded there. Moving on very quickly, we're looking at all kinds of assemblies and parts that are manufactured that can be placed on into Revit. So here we're actually looking at a export into Revit for a robot arm, and we're actually importing from Revit for the floor plan that we can use in order for us to position our and use that floor space in order for us to do our designs. Now, if you look further on, you're using the simplify command as we discussed earlier, and using the default master state view, and then a simplification for the part to make it into a Revit model. This is to allow the Revit not to have to use so many resources. Now, as you just saw there, what it's doing is that it took away all of the bolts and nuts and everything that's of max diameter 0.65 inches and the removal of each of these filtered parts. Now, what it does is it actually recognizes, then removes all of those features, and then creates a Revit model, a lighter model that you can export into Revit so that you're able to drop it into Revit. So same thing, it's doing another it's taking the entire floor plan and creating an envelope with it, and then we're taking this particular assembly out of it, and there's a preset, like I said earlier, with regards to the type of removal or how much of detail you want to remove. And then once that's been exported, then you take it into Revit. And once it's been taken into Revit, or you just pull the digital twin into the Revit factory model, and there's your bill of materials and part files, and one by one you can actually go and label every single piece of equipment that has been modeled and brought in. You can do a live update directly from Inventor through to Revit, and you do the update automatically, and then it'll update it for you. And as such, it will also allow you to, the bill of materials also automatically updates as a result of that. Let's do a quick recap of what we spoke about today. We spoke a little bit about Inventor shortcut keys, sketch constraints, model states and the incorporation into the drawing environment, positional references, and the incorporation into the drawing, simplification, shared views, and your Inventor collaboration tools, the bolted connections we spoke about a little bit, the end cap for a frame generator, and we spoke a little bit about 3D dimensioning and the retrieval into the drawing. We spoke about the weld calculator, the tolerance analysis, and the interoperability of Inventor with other software. How can we help you? We will consult. Let us show you how. Let us within the data management CAD/CAM environment and so on. Anything that Autodesk has that's available, we can help you, whether it's from the manufacturing industry or from the build industry or the civils. We offer a variety of training programs and tailored to your requirements, from basic fundamentals all the way through to specifically tailored for, say, one-day consulting or one-day training for a specific purpose with specific things. Now, Inventor has so many different options that we can pick up a specific training session. We also provide access to CAD Learning, which I spoke about a little bit earlier, is a very convenient e-learning portal that allows you to learn at your own pace. Anything Autodesk related that you would like to learn, it has a list of videos, and at your own pace, at your own speed, whenever you feel like it, at your own convenience, you're able to go and learn what you want to. Those are three of the ways in which we can assist. Then we also have a portal on our website, relatively new, that we've actually recently put on. It's called the Transformation Tools section. In there, it contains ebooks, online courses, videos. We also upload our webinars on there. This is a few of the ideas things that we have on there that are a little bit value-added stuff that's not necessarily, that is not available in the standard package. We do have 2 offices, one in Johannesburg and one in Cape Town. And then we also have presence on social media. You can just take down the contact details of either one of the offices and give us a shout if there are any further questions that you would like to have answered. All right, so thank you very much, ladies and gentlemen, for attending, and hopefully it's been useful to everybody.